Have you ever just stopped and wondered how your world, well, works? I mean, how your bank instantly knows your balance, how your favorite game saves your progress right where you left off, or how a streaming service seems to read your mind? The answer, my friends, is hiding in plain sight. It's the silent, super organized power of the database. So let's dive in and see how we go from total data chaos to crystal clear clarity.
Come on, think about it. You finish a show and bam, a new recommendation pops up that feels just perfect. Is it some kind of magic? Not quite. It's an incredibly smart system, and right at its heart is a database that's doing some seriously heavy lifting. And you know what? This is the perfect place for us to start our journey.
Okay, before we can even manage data, we need to understand what it actually is. It all starts with this pyramid. See, at the very bottom, you've got raw data. The number 38 means absolutely nothing on its own. But give it some context, and it becomes information. A score 38. Now we're getting somewhere. Add meaning to that, like comparing it to the total, and you get knowledge. 38 out of 40 is a great score. And finally, when you use that knowledge to make a call, that's wisdom. The entire goal of a database is to help us climb this pyramid, and fast. So, here's our game plan for this explainer. We're going to start with the messy problem that kicked this all off. Then we'll introduce the solution, look at the different tools of the trade, see how they're impacting your life right now, understand how they're built today, and finally take a little peek into the future. All right, let's rewind the clock a bit. Before all these sophisticated systems we have today, the world of data was, well, it was a mess. A really chaotic place. Welcome to the era of the flat file.
No, seriously, just try to picture that for a second. Every single course list, every student's grades, every professor's schedule, all stored in separate, totally disconnected text documents. It's a digital nightmare waiting to happen, and for a long time, that was just how things were done.
So what's so bad about that? Well, this is where you get a crazy domino effect. First, you have massive redundancy. A student's name is probably copied in 10 different places. Now, what happens if they get married and change their name? You have to hunt down all 10 files. And if you forget one, boom, you've got inconsistency. Your data can't even trust itself anymore. On top of that, these files have terrible security. And this is a big one. If two people try to edit the same file at the same time, the whole system could just crash. It was fundamentally broken. And this brings us to the hero of our story. Because out of all that chaos, a completely new approach was born, one that was designed to solve all of those problems at once. The solution has a fancy name, a database management system, or DBMS for short. This is the key piece of software we actually interact with. It's not the data itself, it's the manager of the data. It sits between you and all that messy storage, creating a layer of order and, more importantly, safety. And this analogy just nails it. You don't get to just wander into the giant warehouse of data and start grabbing things. Nope. You make a request to the security guard. That's the DBMS. It goes and finds the data, checks your credentials to make sure you have permission, and then brings it back to you, all neat and tidy. It handles all the messy complexities so you don't have to. Okay, so we've got a manager, but what kind of data is it managing? Well, it turns out there are two major families of data out there, and each one has its own philosophy and its own set of tools. On the one hand, you've got SQL, or relational databases. Think of these as the ultimate organizers. Everything has to fit into neat tables with rows and columns, kind of like a spreadsheet on steroids. They're called relational because you can link the tables together, creating this beautiful web of connected, consistent information. It's perfect for things like banking or inventory systems, where every single transaction has to be perfect. But then, the internet exploded. And that brings us to NoSQL. This is for the messy, unpredictable, human data. Think social media posts, photos, real-time gaming data. It's all about flexibility, massive scale, and crazy speed. It was born because the old rigid boxes just couldn't handle the chaos of the modern web. And these aren't just abstract ideas. These are real technologies that power the world's biggest companies. In the SQL camp, you have giants like Oracle and MySQL. And in the NoSQL world, you have names like MongoDB and Cassandra, which, by the way, is famous for handling the insane amounts of data at places like Netflix and Facebook.
Okay, so this is the crucial part. This isn't just theory for computer scientists. You're interacting with these powerful systems constantly, every single day, whether you realize it or not.
Let's go right back to where we started, that streaming recommendation that feels like pure magic. So here's how the magic trick works. A NoSQL database, like Cassandra, is storing not just your viewing history, but what you browsed,
what time you watched, even what device you were on. And it's doing this for millions of other users, all at the same time. The system then analyzes all those data points in real time to find patterns and power that incredible recommendation engine. It is the perfect job for NoSQL because of the massive scale and speed it requires.
Now let's shift gears to another world that moves at the speed of light: online gaming. Right, so when you're in a massive online game, millions of things are happening every single second. The database has to track every player's location, their stats, their inventory, all in real time. This is another place where the raw speed and scalability of NoSQL databases are absolutely essential. There's just no time for rigid, structured tables when a million players are all doing something at once.
So, we've seen what these databases do. Now, let's look under the hood a little and see how they're actually built into the websites and apps we use every day. Turns out, there's a standard blueprint for doing this safely.
It's called the three-tier architecture. It's pretty simple, actually. First, there's the presentation tier. That's just the website you see in your browser. When you click something, you send a request to the second layer, the application tier. You can think of this as the brain of the operation. It runs all the code to figure out what you want. And only then does it talk to the third and final layer, the data tier, which is our secure, locked-down database.
And this right here, this is absolutely critical. Notice that you, the user, never, ever touch the database directly. That middle application layer acts as a firewall, a security guard, and a manager, all rolled into one. This structure is exactly what makes modern web applications both secure from attacks and able to scale up to millions of users.
But you know how technology is. This field never stands still. The challenges of data are always getting bigger, and the technology is constantly evolving to try and keep up.
Two of the biggest trends blowing up right now are cloud databases, where companies don't even need to own their own servers anymore and can just rent space from services like Amazon Web Services, and real-time analytics. This is the amazing ability to process information the exact instant it's created, and it's what powers everything from stock market trading to that dynamic pricing on your rideshare app.
So there you have it. From messy text files to global cloud networks, databases have evolved to become the invisible skeleton that supports our entire digital lives. They bring order to chaos, they help turn raw data into actual wisdom, and they power the services we really can't imagine living without. The only question left is, what's the next big problem they're going to solve?